it's an interesting problem to look at. And that's when you start to see how these worlds come together of automotive and IoT. Because as more and more performance goes into automotive and as IoT becomes more pervasive, it really just starts to look like a network of networks. Everything is just connected.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. Fast forward 10 years into the future with me. A brand new 2033 model sedan goes whizzing by. The driver is reading a magazine, not looking at the road, as the car drives itself merrily along. How great, finally a self-driving car. But from an engineering perspective, this autonomous vehicle is maybe best described as an IoT device, or maybe even a mini data center. The lines here are a bit blurry. Okay, rewind back to today. If you look closely, these lines are already blurring. For example, today's guest, Dipti Vachani, is the Senior VP and General Manager of both the Automotive Group and the IoT Group at ARM. That combination of IoT and automotive would have seemed odd 10 years ago, but today it makes perfect sense. Well, to me at least, and I suspect by the end of the podcast, you'll agree with me. Dipti, thanks for joining me in the lobby today. I'm really looking forward to this conversation.
Thank you for having me.
How did you get into technology? What got you excited about engineering and tech?
Gosh, it started in high school. I had a crazy math teacher, Mr. Johnson, and he had this crazy wild idea that he wanted to start a computer science class. And now I'm really aging myself because that was not something that we didn't even have computers or a computer lab of sorts. And so in order to start this class, he had to have a minimum amount of students. And so he just walked up to me and said, you're good at math. You want to try this? And he was a good teacher. I usually made A's in his class. So why not? Right. And it was a kind of a why not moment that led me into his class. And I just loved it. I fell in love with the idea of being able to write some code and magically make something do something for me, right? It's like I can write some lines of code and it's going to do what I want it to do, and I can make it do anything, which was amazing. He ended up driving me around all over the United States doing all these computer science contests, and we started winning state competitions and national competitions, and the rest is history. So we just had fun with it.
What sort of competitions were you doing? What did they look like?
This is really aging myself now. So we'd sit in these little desktops. We'd have these massive computers, and each one of us were given these computers, and they would hand out this piece of paper that said program X, whatever the contest was of the day. And so so it was all typing skills. Let's quickly program this thing. And then you saved it on a floppy because there was no other way to get it to the judge. You saved it on this floppy. And then it was about taking this floppy and running to the judge's desk as fast as you could. And the first person that got the floppy to the judge that actually executed won. That was it. And so it was typing skills, programming skills, and how fast you can run. And if you could trip the boys on the way up there. And that was my thing. I just, if I could trip them or elbow them on the way up, I did. And I won. So it was that simple. It wasn't like it is these days.
That's fantastic. No emailing code back then, I guess. Huh?
There was no way to do that, right? It was just
no git commits.
Yeah, but it was fun times. It was fun times. We had a good time with it.
We found our listeners have kind of a nostalgia for old computers. Do you remember what computers you were using?
It was. I was thinking about that. I do know it was Pascal and Fortran that we were programming in. So that'll give you some idea of how old it was, right? It was back before C++. We didn't even use that back in those days.
I think the last time I ran into Fortran, I had a roommate in college at Texas A&M doing nuclear engineering, and that's how they coded the nuclear reactors. I hear you're an Aggie as well.
I am an Aggie. Yeah, you're speaking to my heart when you mentioned that.
So gig 'em.
Yeah, gig 'em.
What did you study at A&M?
I was computer engineering. It's interesting how life works because now you look back and you think how genius it is to have a degree that's in computer science and electrical engineering, right? And both combined into one degree. But back then it was just an idea of why don't we combine these two? And for me, it was more, I've been doing computer science throughout high school. And so the classes were really kind of boring. They were so basic compared to what I'd been doing in my contest that I decided to add something to challenge myself. And that was the electrical engineering side of it. And Magic came out with computer engineering, which today, if you look back in hindsight, it's genius. But it wasn't that thoughtful at the time.
So if your classes were easy, was there anything that was difficult or unusual or stood out to you about your time going through engineering school?
Well, I was the only woman in my graduating class. So that was glaringly obvious. And I grew up with three brothers. So I was used to being around guys. It was just something that I was comfortable with. At the same time, it is fairly isolating and lonely not to have that kind of community. I think times have changed. There's more. We still haven't gotten there yet. We still have a long ways to go to have some sort of equity in this field.
I really want to hear more about that, but let's circle back on it later in the podcast. Staying on the education theme, you have degrees from some pretty big name colleges, Harvard, Stanford, Cambridge. How have those served you in your career, both early career and later in career where you are now?
Sure, at the beginning of the career, it's all about the computer science class, the electrical engineering class, the circuits, the chemistry, the physics, the optical classes that we took in school. And those are all necessary. I think it helps you think about how to think about problems more than anything. It's not that I remember anything beyond really algebra as far as math is concerned, right? Tell me to do a differential. Maybe I could do that. But I think later on, most of these other places I've been to were executive degrees where you're really looking at case studies, companies, businesses, how they work through problems and thinking about how you would look at that differently and how you can apply it to the companies that you're working for now. That I think is how it changes. And one of those things I always say, the more you know, the more you realize you don't know. It's like, it's the more educated you get, the more stupid you feel, right? It's like, wow, I didn't know that, right? There's so much I don't know.
Yeah.
And it's kind of nice early on when you think you know it all, and then you realize I actually don't. I actually don't know it at all. And there's so much to learn, right? And then on top of that, our field is changing so fast, right? I was getting into the details of how a neural network processor works, and it's amazing to me. It's just the amount of math that happens and the matrices that are happening in there. It's amazing to me. And that's completely brand new. That was nothing that I learned in school. Artificial intelligence, they started teaching that when I was in school, but we did it in such basic ways compared to what we're talking about now.
And then out of school, you went to Texas Instruments. Can you tell us a little bit about what you did there and kind of an overview of your time?
Yeah, I was there for 17 years, so I did a lot while I was there, and it's an amazing time and an amazing journey there. I started out as applications engineer, and I still look back at that job as one of the best jobs I had. Like 30 some odd years later, I look back and say it was fun, and no day was the same. You came in and you took technology to solve problems for your customers. And so a customer would have an issue, you figure it out, you work hand in hand. And when you figured it out and they were happy, it felt like joy, like you accomplished something. These days, I wonder, you end the day and you wonder if you've accomplished anything. And back then it's fun. You got to actually I got to work on real world problems.
Were you working with ARM processors at that point in time as well?
Yeah. So TI was one of ARM's first customers. And it was all ARM technology in the embedded processing. I was working on ARM technology from the early days, from the inception of ARM. It's amazing because there's a part of your solution you knew just worked. And so then you could focus on all the areas that allowed you to differentiate. And that's what made ARM so cool at the time and allowed me to grow some of those businesses that I grew inside of TI, was having just a big portion of the solution just work. And then you can work on all the other stuff.
What sort of businesses were you working on? What industries were you looking at?
Oh gosh, we did a span of almost 17 years. You can imagine there's all kinds of businesses. DSPs. Most people have heard of DSP technology from Texas Instruments. So DSP technologies of course, the processing space. We started the business that is Sitara inside of TI, which is an ARM solution. And that was mainly targeted at sort of in the industrial space, but spent a lot of time in the audio space. Back when iPod was the first brand new thing, we worked on that. And we had these digital CD players. That was another business that I worked on there, which is a brand new concept. And I also spent some time working on the automotive space inside of TI. So got to do a span of many, many different infrastructure. Back when we were looking at ASICs for infrastructure solutions, data centers, gosh, that's grown so much since then.
So much so in conjunction with automotive. And that's something that I found interesting is how automotive and IoT have really blended together over the years. Did you foresee that happening? As you worked on these different technologies, did you realize that it was going to start blending, kind of like the computer electrical engineering majors coming together? Or is that happy accident?
I'd love to say I could foresee it or I had it all planned out. But honestly, if you look back, and I'm going back to that time when we first started putting digital amplifiers inside of cars. That was the business that I was working on. So it was the transition between analog amplifiers in cars into digital amplification in cars. And then this idea that if you had a digital amplifier and your car was going to stop at a red light, would your audio turn off? And how do you keep the power going to your audio? And kind of very basic questions that today we've solved all of those. But that was where we spent a lot of energy around. And then if you had digital amplifiers, could you reduce the wiring inside of cars? How many speakers could you put inside a car? So those are the problems we were solving. IoT was very much focused around kind of the early days. It was home automation or just personal devices. Those worlds seem so far apart, very low power, low code kind of environments to complex wiring and complex environment in which you're operating in, right? Power and performance kind of things. And so, no, they seemed like worlds apart back then. Maybe some of the technologies are pervasive. We use ARM in both, and we used ARM in the amplifier space as well as in the IoT space. But from a market perspective, they still seemed diametrically different back in those days. And here we are. Things have changed since then, haven't they?
They sure have. Yeah. So when you moved from Texas Instruments to Intel to do IoT, what sort of experiences at TI set you up for the Intel role, and what did you do at Intel?
So at Intel, I was also running the IoT product space. It was interesting for me because Intel plays very much in the high-end portion of that market, large screen compute, laptops, and data center, and the IoT space. And so there was only so far they could go into the IoT space. And the job that I had was to see how we can expand down even further into that space and look at that product offering in totality. And so it's an interesting problem to look at. And that's when you start to see how these worlds come together of automotive and IoT. Because as more and more performance goes into automotive, and as IoT becomes more pervasive, it really just starts to look like a network of networks. Everything is just connected. And everything in some point is required to have some connectivity, have some processing, and they all come together in decision making. And so that's where the complexity of the network of network problems started to come to light, that the understanding of how can you span this entire spectrum of data center down to the smallest of things and create an environment such that it can scale. And that's a very big problem for IoT.
Let's keep exploring IoT, but first we got to take a quick break. I'm joined today by George Harriman from Rome. George, thank you for being here.
Thank you for having me, Daniel.
So I know technology is always changing. What are you seeing today, particularly around the space of gallium nitride devices?
More speed, more data, and more power is required, such as 5G applications or more servers needed. So that is where gallium nitride as a wide bandgap semiconductor is able to provide a more efficient power supply solution.
So who should think about using gallium nitride transistors? What applications are they getting used in?
Yeah, so some of the applications where Rome's 150-volt GaN devices can be used, for example, data centers and base station where 40-volt to 12-volt power conversion is required, and some other applications such as motor drivers where 30 volt batteries or 48 volt batteries are being used, and also applications such as LiDAR for self-driving vehicles.
Is there anything that makes Rome's GaN technology stand out?
Yeah, so the first one, Rome's 150 volt GaN devices have a higher gate source voltage rating that can withstand 8 volts compared to other solutions that can only withstand 6 volts. This is important, especially during turn on of the FET device, as overshoot from the gate driver may damage the device if there is not enough withstand voltage. The second one is Rome's 150 volt GaN FETs come in an industry standard DFN package with copper clip technology inside, so no wire bondings for very low inductance. And also because it's a DFN package, it's much easier to do a PCB layout compared to some other solutions that use a ball grid array type of a package.
So if this sounds like a useful device for somebody, where should they go to find out more?
Yeah, so please visit rohm.com.
We're back with Dipti Vachani, Senior VP and GM of Automotive and IoT at ARM. Dipti, before the break, you said that scale was a big problem for IoT. What are the factors playing in here? Why is scale an issue?
We've seen a lot of major shifts in markets, right? We saw it in the cell phone, the mobile space. We started to see it in home. But this was the first time where when you look across the board, there was no market that wasn't impacted. Every market in the world every industry was being transformed. Industrial, retail, home, cars, agriculture. There is no market you can mention that isn't somehow impacted by this pervasiveness of artificial intelligence, IoT, ML, connectivity. And so when you step back, technology has been available for a really long time. It wasn't really the technology piece that made this an aha moment. It was the fact that every market in the world was transitioning, was going through a major evolution or revolution, really. That makes you realize when you sit back and you think about what markets you're going after, there's no one market that isn't impacted.
I know you just said that it transcends an industry, but are there any industries in particular that you see IoT having an extra big effect?
Whatever industry you're in feels like it's that one, right? So it's one of those questions of perspective. From my perspective, gosh, there isn't one that isn't healthcare. We saw it during COVID, how things transitioned even in healthcare where we weren't able to get to hospitals and doctors necessarily. And we were starting to do things more from home or industrial. The industrial automation. If you've walked in a factory anytime recently, and I've been in factories throughout my entire career, and I've seen, you go in there and it's a ghost town. There's not a human around. Everything is automated. It's amazing. That's just in the recent years, you start to see that major shift. And now that human capital is no longer as big of a variable in automation, how has that changed the world economics and where we do manufacturing? That's an interesting question. So the impact is, it's happening across all industries, but you'll see it in some more than others. Automotive is going to transition into fully electrified and fully autonomous cars. That's just a matter of time. The technology is available today. Now it's more whether we can get the infrastructure ready for something like that. I think our lives, as we saw maybe 5 years ago, to what's going to happen in the next 5 years is going to be dramatically different.
Well, I'm here for it. I can't wait for autonomous driving. The quality of life and the safety factor alone for me would be significant.
You say that and I say that. I was just in a fully autonomous vehicle in the streets of Jerusalem, and I can imagine trying to do that. Nobody follows any rules out there, so it was cars everywhere. It was pretty amazing how it navigated that, and I had no issue. And people would ask me, "Weren't you scared?" And I said, "Absolutely not. I knew that thing could do a much better job than I would ever do." But at the same time, there is a fear of change and a fear of the unknown and the fear of what that is. You and I could probably logically come up with a conclusion that it's much safer, but it's the lack of control that's fearful.
When do you think society will get there? And when do you think we'll be ready for it? Or is it more of an infrastructure challenge than a psychological challenge?
It's both. It's both psychological and infrastructure. And gosh, if I gave you time, it'd be wrong. Every year, it's like the next 5 years, and then it's the next 5 years. And so, these things always take longer than we think it's going to take, especially from our lens of technology, because we built it. It's ready to go. Let's go. That's kind of my attitude, right?
Yeah.
I've got it all ready. We've got the low power. We got the solutions. We know what to do on the ML side. Hard problem is the software. We're still figuring that out, but software can be deployed in real time because we work on software defined vehicles. And so that can be deployed in real time. And from our perspective, we're saying, let's go, but it takes a bit longer than we always want.
So we have the floppies, we're running down the hallway, we slap it down and they just have to execute the code, but they're not doing it.
And we've tripped all the guys on the way up. That's of course. Punch them too if you have to, but winning's all that matters.
Love it. So what got you excited about ARM and how did that transition from Intel to ARM? What did that look like for you?
You get to a point in your career where it's, how can I leave a legacy? How do I make an impact that's significant? How do I look back and say, I did that, or I made that impact, or I was part of that journey. I can't think of a better company in the world to be a part of, to do that. It's amazing that this smallish company, if you think about in the grand scheme of things, it's a pretty small company. It makes the impact and punches way above its weight in the ability to scale and transform markets. And if you think about the IoT market, let's pause and just think about that. The IoT market was built on ARM. Everything we did in IoT was built on ARM. And what we did at that time was use a lot of the mobile technologies that ARM had released and used them and reused them into IoT. And so that entire market came to light because of it. I think automotive will scale because of ARM. I feel like I'm in a place with the reach and scale and the partnerships and the ecosystem that ARM has to truly make an impact and leave a legacy. And that was what my goal was. And with some incredible people.
So now you're at ARM, and as you say, you're looking to leave a big impact. I understand you have both the automotive group and the IoT group. Are those groups together, and how does that play into your vision for leaving a legacy?
They are. They're together under my privy. So I run both automotive and IoT. That was part of Renee and I's first discussions. Is if you look at both of those markets and you look at some fundamental technologies like safety, security, it's pervasive across both those markets. And you look at the IoT market, is the automotive just an endpoint? Is the car just an endpoint? I don't know. It's pretty complex for that. Is it in itself its own ecosystem? Yes. So it's a pretty, when you kind of dive into it and start thinking about the problem statement, it's pretty amazing that when you pull back the onion, yes, it's an endpoint for all intents and purposes. It's connected to the cloud and it has its own processing. But then within itself, it has lots of networks and network of networks. No different than a factory. Think about a factory. It's not moving like a car, but very similar in the fact that it's connected to the data center and it's a network of networks inside. And so when we look at this technology of connectivity, processing, neural networks, and safety, security, I think you have to look at that problem more holistically. And the way ARM works is we set base technology out there and allow it to scale. And so scale is really how the markets win. And that's our job, is to enable scale. So if we're really going to have scale, this investment has to transition between all of these markets, has to be able to be amortized across all of these markets, because you really can't invest properly in some of these technologies because they do require that unless you're able to amortize that cost across many of these markets.
So what was it like moving from like Texas Instruments and Intel, which have their own foundries and they're shipping out their own chips and hardware, and moving into an IP company like ARM? How is that different, and how has that changed your mindset, both looking back and looking forwards at tech?
There's a double-edged sword to this. When you have your own manufacturing, I want to make X, I just go make X. I'm going to make an industrial automation chip. I'm going to use Intel technology. I've got all the IOs. I know how to do the packaging. I know how to do the manufacturing. And then I worry about scrap and test time. And gosh, how many mornings I woke up looking at my test time to see if it's gone up or gone down and looking at my gross margins that way. That's a lot of your energy. The energy now is how do I make this as easy as possible for the industry to get to market? Because I don't make it. I get to come up with all these brilliant ideas, but then unless someone actually takes it and makes something, it never sees the light of day. And so it's all about partnerships. It's all about ecosystems. And to be able to truly do it, I have to have lots of partners building IP on top of my IP software, IOs, connectivity, interconnect. There's all aspects of this that I need a whole ecosystem of partners working on in conjunction with me. And so it's mainly about how do I scale through partners? And that's where my energy is spent, which is uniquely different than where it has been in BART. But the impact you can make when you do something like this is limitless, right? And then I also think about how do I standardize some of these elements, making it really easy? How do I make it so that it can be interoperable? Because that's where scale happens, is with interoperability. And so that's a whole other spectrum of problems to go solve.
What should engineers be thinking about when they are evaluating whether or not a project should have interoperability baked in?
First of all, if you want your products to be pervasive, then you need to think about this first and foremost. How are they going to operate in the real world with other real world devices around you? And then what happens is this only happens when we have the market and industries come together. And that's how ARM looks at it. So we created technology around PSA, which is a pervasive security standard. And if you enable PSA, now we've got some consistency on security, right? We also look at how endpoints connect into, which is a standard called Centauri, to edge devices, and as well as system ready, which is data center. And so we create standards on both Cassini, which is our edge device standard, and system ready, which is our cloud. So now we have system ready in the cloud, we have Cassini at the edge device, and then Centauri at the endpoint. These standards enable all of this to be interoperable and can work really on any ISA, really built by ARM, but across the industry with co-opetition working together. And so,
Did you say co-opetition?
Yeah. Frenemies, call it what you want, right? And that's the tricky part for an early engineer is, so you want me to work with my competition on defining this standard so that it can scale and be pervasive, which is an interesting dilemma. And the truth of it is we only win when the pie gets bigger, and we're all trying to just make the pie bigger. Often you're sitting across the table from your number one competitor trying to define what the security standard is going to be. And out comes something like PSA, or out comes something like a Centauri. And that's done through open source. So we open source all of it. And then the question is, well, if you open source it all, how are you making money? Well, we make money through scale. We make money by making the pie bigger. So it's not what you learn in school. Very, very different from how things are done in a classroom.
Is this where the executive grad type programs come into play? And what are you seeing from other industries and companies that we need to be thinking about?
Yeah, I mean, of course, right? They do become very helpful, but the standards we use here are very different than what's been used in other industries. So that's a different way of looking at the problem. But I think if you look at how fast our markets grow and how easy it is to get stuck, and I've always done it this way, and that's what you see across other industries, and you see what's happened in the past is the biggest companies in our industry maybe 10, 20 years ago aren't around anymore, and you thought they were too big to die. And here we are today with a world that's completely different. What I recognize is that it's easy to get stuck. We have to keep breaking the problem we solved earlier and look at it completely different. And what worked before if it didn't work before, it doesn't mean it's not going to work now. And also that the next Google, the next Facebook is out there somewhere at a startup with 5 engineers in a garage. And so you got to work with those guys as much as you work with the massive Siemens and the Schneiders of the world. And you got to work with them both as importantly.
I really like that philosophy. Let's take a quick break. We'll be right back. Okay, stop the music for a second. Listen to this. Oh, I really thought that would sound cooler when I planned this out. Anyway, that's the sound of a Moore's Lobby mug, and I want to send you one. In fact, I'm taking the whole break just to tell you that. All you have to do to get one is hop on social media, pull up the Moore's Lobby page, and tag someone in the comments for the post of this episode or other episode that you liked. Tag someone that you think will like this podcast. Word of mouth, or I guess word of keyboard, is the main way we get new listeners, and that's what keeps the podcast going. Also, thank you for being a loyal Moore's Lobby listener. I'm glad you're here, and I've got a mug for you. And we are back. Dipti, how do you and how does ARM approach the various software and hardware challenges of autonomous vehicle design?
If you think about an autonomous car, not even a fully autonomous car, let's say it's just autonomous features, has more lines of code than a Boeing 747, right? I mean, it is the amount of software that is required to enable some of these things. It's such that you cannot think of the problem in isolation. You have to think of them together. How is this software going to be reused across multiple versions of silicon? Because I can't afford to rewrite it again every single time there's a bespoke solution. I changed something small and now I've got to rewrite the entire software. It's not practical. And you could do it, by the way. In hardware, it's really easy to do that. You'll make something better and break all the software that's ever written, right? Well, you didn't really make it better, right? So I've done that. I'm not.
Can you tell me about? Can you share the story?
Well, it was just an interface. I won't go into all the details. It was just it was a very basic interface, something like PCIe, and we decided to make it better and break the entire ecosystem of software that came out. And it's like, well, okay, now what do we do? And the only way to fix it was to spend all the money and another tape out, which, tape outs these days, well, back then were several millions. Now I can get into much more than that, right? Back then I'm dating myself with several millions of dollars and you're like $10 million to fix something. That was just a small little optimization. But that was a problem back then. Can you imagine now it is much more significant of a problem. And as such, you have to think of those things in conjunction. And when we think about this, that's why ARM has to look at the problem more differently. We often thought about the problem as a CPU problem. If you look at the stuff we're doing in automotive and in IoT now, all the stuff that we've done recently with solutions, we now put more than the CPU together. We put a heterogeneous compute block together, and then we enable software infrastructure on top of that heterogeneous compute block. So there'll be an ISP, a CPU, a GPU, because it's no longer just about the CPU. Optimized computing is required for these solutions. We put them together with the interconnect and we say, okay, here's the software ecosystem on top of that. So there's a standard like SOFI or something we're doing in Corestone and IoT that now allow for folks to scale software on top of a solution, because we can't look at it in isolation anymore.
Yeah, I never thought of heterogeneous compute being an automotive play, but it seems obvious now that you say it, with all the different types of sensors and information coming in.
It's all about heterogeneous compute. The heterogeneous compute is what's going to allow it to finally get into a power performance cost window to enable something like that to scale. I mean, a car, the trunks that I saw early on, and I would just say only 2-3 years ago, we call it the junk in the trunk, because it really is that. It's just this trunk full of just all this processing, right? And it's $100,000 of processing. How is that ever going to scale on the road, right? And it requires charging every 5 miles, right? It's not going to work, right? And so it is only when we start to look at the problem as a heterogeneous compute block that we start to get it into a reasonable power performance cost window. And then we start to say, how is safety pervasive? How do we look at safety, not just in what they're doing in the old days, which was redundancy? Just put two exact same systems right next to each other, and there you have your redundancy and there's your safety. Well, you can't do it that way. You've got to think about it as an entire ecosystem, and how do you create safety within the IP itself. And we look at that in ARM, and then also at the system level and at the software level and at the system inside the car level.
So what does it look like to design for safety? What's the approach?
So you think about when we make IP, often we thought of safety from a standpoint of a system level safety. Like I just said, we put 2 CPUs down or we put 2 redundant systems down, and that's how we create some of the safety architectures. Now we look at the problem slightly differently, and we have a feature inside of some of our IP it's called split lock, where we actually have two different processing blocks inside of the IP itself. We split the processing and just the IP itself, which allows for the solution to be easier implemented. Well, then you say, well, how's that much better than when if you were to put two systems right next to each other? Well, it is that much better because you're not having to package two different solutions. You're not having to power two different solutions. But even more so, it's that much better because when a system doesn't need safety, because remember, not everything in the car needs safety. There are certain critical features that do and others that might not as much. When they don't, then the CPU can operate as one big CPU. It doesn't have the split lock mode anymore. So it's one processing unit. And that solves a problem because now you can have the same silicon in multiple places. In some cases, you can split it. In some cases, you don't have to. And it maximizes the ability to write code. So this is just one example of multiple ways that we have started to innovate in terms of safety. And then the other question we start to ask ourselves is what's happening in the car is more and more compute happens and we centralize this compute. So now we're starting to centralize compute. And what happens when you start to centralize compute? That means IVI, stuff that's in your in-vehicle entertainment. Let's say, I hope you're not watching Netflix. Maybe the passenger is while you're driving, right? Well, wait, you could once it's fully autonomous. But things like that's inside the car and your lane change or your distance monitoring and your inside of the ADAS system is all in one compute block. And those workloads are all sitting next to each other. So you get safe workloads sitting next to non-safe workloads. How do you look at that problem? And that's when we talk about some of the features that we just released in V9, which is confidential compute, keeping this compute extremely confidential amongst each workload. So it's pretty amazing the kind of innovation that's happening with regards to safety and workloads and how we start to look at these systems as they integrate and start to look more like a fully self-sustained computer on wheels.
I've heard the future car described as a data center on wheels.
Yes, my old employer, I think, coined that word.
Oh, yeah? I'm picking up on something. Do you agree?
Depends how you look at that problem. It can't be in terms of power and performance. We've got to look at that problem differently. And it has to be looked at differently from a safety standpoint. When you think about the amount of compute, possibly you can start to look at that as levels of data center. We are starting to use some of the data center IP that we've created for data center inside of the car. So we are reusing that. So then from that standpoint, you can say that. But then again, the problem around safety and power has to be looked at differently. And the heterogeneous compute problem, right? Because the workloads are different than what you think of in a data center.
I guess a data center doesn't have to worry about crashing into a pedestrian.
Yeah, no. And the real-time nature of it. Think about the real-time nature of a car, the real-time compute nature of a car.
What excites you about the IoT and automotive space today?
I talked a lot about automotive. In the IoT space, I've been talking about, I used to say IoT was all about the concept phase where we created all of these proof of concepts and they were beautiful in a warehouse and then it never got anywhere. It never solved the problem there. So we all would brag and we'd flex our muscles and look at how this cool system we created that never saw the light of day. And we're finally starting to see scale. And a lot of that scale has to do with software and standards. I talked about some of those early on with security standards, with some of the stuff that we're doing on standards at ARM, but also just getting software pervasive enough of an ecosystem of software developers that are enabling that to scale. And so we're finally starting to see, I think, the scale we've been waiting. It's always been the trillion devices. We're there, I think, at the scale problem. And that's what I think we're going to see in the next few years.
We had a guest on a couple episodes ago, Kim Polfson from Universal Robots. He's their CEO and president. And he was talking about how when he was at Siemens, they would do these presentations about IoT and then they didn't really necessarily believe it in-house. And then 10 years later, they were looking back at their presentations and just like, it was bigger than we thought. Like it was bigger than we talked about. And we were kind of skeptical of these pitches.
Yeah.
Is there an analogy for that now? Do you think IoT is bigger than we realize, or do we have a good idea of the scale and what it's going to take to implement that?
It depends. There's so many different analysts on this, but I think the part of the scale that You brought up universal robots, and it puts to mind the part of the skill we haven't really internalized is the robotic element of it. How the interface between robots and humans are going to be and what that's going to be like. I used to have this pitch called "The Robots Are Coming." Right. That was my presentation because I truly believe they are, and they're going to be a part of our lives in multiple aspects. And to some, that's a scary idea. And to others, imagine what we can do for those that are in hard to reach regions of the world or healthcare in small villages, right? It's just the amazing things that we can do as far as sustainability if we can implement some of the robotic concepts that we have. And I think that's part of the problem with AI and ML that I don't think the common man has really internalized is the element of robotics and how that's going to be a part of our life.
Can you expand on that?
Think about just healthcare and how it will. And then the question is, are doctors going to go away? No, they're not going to go away. Of course not. But are there going to be supplements of robotics that's going to play into how healthcare is done in the future? And are we going to need less of some and more of the other expertise? Right. My daughter wants to get into healthcare, and my caveat is, fine, but you better have some data science and machine learning or artificial intelligence as part of your degree. That's all I ask is you have to have technology as part of your degree, because those that are going to survive are going to have some element of technology understanding, because that's what's happening to all of these fields. Think about agriculture and the kind of monitoring we can do underground with water so that we save water. That's going to be part of that field, whereas it's a traditional field that hasn't had technology as part of its pervasive knowledge base.
That's really good advice. Let's take a quick break. We'll be right back. I have a confession to make. I have a really bad habit when it comes to listening to podcasts. Sometimes I just forget a podcast is out there, even a podcast I love. Maybe there's like a break in seasons or I just miss it sometimes. But I'm sure that would never happen to you for the Moore's Lobby podcast, right? Well, I have a way for you to be sure. Go follow All About Circuits and Moore's Lobby on your favorite social media platform, but probably not TikTok, because I don't think we're on TikTok yet, but that could be fun. You also might get fun factoids like this. George from Rome, remember from the first ad break we were talking about gallium nitride transistors? He actually used to work on one of Dipti's teams. We didn't plan that, it just happened. So all that to say, go check us out on social media, and let's get right back to it. And we're back with Dipti Vachani, Senior VP and GM of Automotive and IoT at ARM. Dipti, I saw one of your credentials was listed as crisis management. Can you tell me a little more about that?
Well, if you've been in this industry for as long as I have, of course there's been crises, right? I mean, that's just how the world works, right? And what's a crisis, right? In most of my life, those have been customer line downs or major customer issues, right? That means we stop, everything stops, and everything is about the clock ticking and how fast it takes to get the problem solved, because they can probably articulate to you the millions of dollars they're losing every minute. And you talk about automotive, that's a whole other world, several millions dollars
Yeah.
the line when the line is down. And so it is managing through that. That means managing your customer, managing internally, managing externally, managing the press if that's what's required. So it's a pretty complex problem statement in our industry. But at the end of the day, it really just comes down to the team that you have. That's when it's obvious to you whether you get the best team or not, right? And I've been lucky enough to generally say that I have at ARM. We definitely do. And you just come together and it's about solving the problem. And the worst thing that can happen in a situation like that is when you start to get the CYA or the finger pointing. That's the thing you're trying to avoid at all cost.
Yeah, that's definitely never productive. What was the transition like for you to go from heads down technical applications into management? How did that go?
I'd love to say it was fun and glorious, but it was actually a very, very difficult transition for me. First of all, I loved technology and I loved what I did. So it was one of those things where they tapped me on the shoulder and said, "Would you like to do this? We need a backfill and it's going to be you." Like there was a fear, number one, of losing touch of technology. And I have to admit, to a certain extent, I have. I could probably lay out a chip like the best of them still. I think I can, at least in my head I can. And I can still write code, but nowhere to the extent of the engineers in my organization. They're 10 times better than me. They're much smarter than me when it comes to that because it's just been a long time. And so you do lose touch, and that's the fear. And so you got to decide when that's the right time for you. To a certain extent, you will. But the other part of the problem was when I first got my job, it was a good friend of mine that was on the team. He decided to quit because he couldn't work for a woman that was half his age, in his opinion. I wasn't, but I guess he thought I was. And that was a tough one. And I remember going to my boss saying, did you make the wrong decision? Because you just lost a talented engineer because you put me as the boss. You didn't want to work for a woman. I'm lucky to have had a great mentor at that time. And he said, hell no, we filtered out what we needed to filter out at that point because this is the future. And so now I look back, I probably should have been, well, hell, that's fine if you want to leave, but you're young, it's early, right? And you worry that each step of the way you're self-reflective on, am I making the right call?
That's hard.
Yeah, it was the first. It's when you learn that you can't make everybody happy, and not everyone's going to like you. So it is what it is.
Once I realized not everyone was going to like me, my life got a lot easier.
Isn't it? That's just life.
Yeah, like that was the right call, and they didn't like it, but that's how it goes sometimes.
It is the right call. Reflection it is. Obviously it's the right call, right? But when you're in it at the moment and it's a good friend, or at least I thought it was, right? And you're young. And that's the hard part, right? That's why I mentor so many young women because it is damn hard. It is, and we lose a lot of young women in the career path because of some of this stuff that just gets too hard to bear over the years, right? I could tell you stories that would be embarrassing of the things that I had to endure through the years of working in a very male-dominated industry. They're exceptions; they're not the rules, but enough exceptions add up that it can be hard for a young woman trying to navigate her way through this industry.
So what advice would you give to the women in tech listening, and what sort of guidance do you give to the women that you're mentoring?
Well, a couple of rules I have, and I tend to follow my life in rules. I put very strict boundaries on myself. Work for someone that believes in you, and you know it, right? First, you got to prove yourself, but once you've proven yourself, work for someone that believes in you and vote with your feet. If they don't waste your time. Get the hell out of there. I say that no matter what company, no matter where I am, if women are going to thrive in this industry, it's important that they have someone they can rely on to have their back. And I wouldn't be here today if it wasn't for actually white men, because that was all that was in my industry back then, right? And they've taken care of me and they've helped me through this entire journey. And so there's plenty of them out there that are willing to help you through this journey. So make sure you work for someone that believes in you. Find a community. That's the thing I didn't do, and it probably got me to a breaking point. And I know that I won't get to a breaking point now because I do have a community of girl power. I mean, just some of the most amazing women in the industry that I can tap into at any given point that I can vent to. I can say all the things that I would never say out loud to anyone else, and they'll listen and they'll give me advice and they'll be there for me through it. So find that community. You can have that community amongst men. I do. I have a community of men that I work with that I really, really enjoy and I think of as my friends and my dear, dear friends. But you also need it with other women. It's just as important. They provide a different perspective. So I think it's just important to have that. Make sure you have people that will advocate for you. There are mentors, but you need advocacy. Those are two different things. Make sure that there are people out there that can speak to your skills and your capabilities in a room where you're not. That's fundamentally why I'm here where I am. There were people that are willing to speak in rooms where I wasn't that said, she can do it. Try it. I bet you she'll knock it. Or you know what? She can do it and I will have her back. I will make sure I will put my career on the line or my name on the line to say that she's going to make it. And I will work with her through the whole journey. I've had men that have done that for me, and I wouldn't be here today if it wasn't for that.
So I've had women engineers on my team, and I'll be honest, it was tricky figuring out how to best support them. What advice do you have for me if I'm in that situation again, or for our listeners who have female engineers on their team?
First of all, listen. It's interesting. It's interesting because I have a lot of well-meaning men around me, and I have through my entire career. And often they want to come in and try to solve problems for me or to protect me. And that is absolutely not what I want. And so, and it actually offends me more. Like, what did you think? I couldn't protect myself, right? Do you think I need protection? Have you seen me out there? So I just say, I just say, listen and listen to see what they actually want, what they really want. And often maybe it's just a vent. Often it's maybe to share. And when they share a problem, like someone did X, your natural instinct, and so is mine, because I'm mama bear, is to go on there and punch them in the face or to tell them they were wrong and they shouldn't have done that, right? That's what your natural instinct is going to be. Hold off. Ask her what she wants you to do. Ask the question, what would you want me to do? How can I help you? Because she may want to stand up for herself and just you to have her back. And that's a different thing. So I just say, listen, and that's what I do. That's what I ask others to do, and be cognizant of how it is that she'd want you to help her in that situation. And then I'd say, advocate. That's what can help us the most, which is in rooms where she is not. Make sure you can speak to her skills, just like you do the other folks, right? Make sure you can speak to her skills and advocate for her. Generally speaking, statistically, women aren't going to put themselves out there at the next level. They're not going to push themselves. They want themselves to be perfect before they'll choose the next level. That's just statistics. We've known that as we look at this industry. And so you might need to push her out of her comfort zone to do the next thing or the next thing. That's kind of my generation. Actually, I watch my daughters, and you say you have 3.
Yeah.
I see a completely different thing there. They're amazing. There's no force that's going to hold them back. There's nothing they can't do. So I'm really, really excited for this next generation that's coming in, because they're a force to be reckoned with, and it'll be fun to see them change this thing even more than I could in my time here.
Just the fact of like growing up with things like AI ML just being integrated into normal life.
Yeah.
As soon as my little ones could talk, they were trying to talk to the smart speakers and trying to,
Yeah.
like unlock my phone with their fingers and that sort of thing.
I know. I remember one day we got Alexa. My daughter was younger at the time. And I remember I was just sitting in the living room. She was in the kitchen. She goes, Alexa, order marshmallows.
Got her priorities right.
I go like, okay. She goes, okay, marshmallows added to your Amazon list. And I'm like, oh shit.
I'm going to have to bleep Alexa, otherwise we're going to order a bunch of marshmallows.
That's true. That's true. Anyone that's listening to us just ordered marshmallows.
As we run out of time here, we like to do some lightning round questions. When you look back on your career, is there any tech that you worked on or your teams worked on that you really wish had made it and maybe just didn't quite get the green light or didn't quite get market traction?
That's a really good question. It is a lightning round question. How am I supposed to come up with something?
I know, sorry.
Because it's the reason I say it's so hard is because when you look back, and I'm going to get really nerdy for a moment, but it was like,
Please.
We created this one of my first solutions that I created in Sitara had this configurable interface, right? And I had this beautiful idea that this configurable interface will allow the user to configure the interface, and they can configure it to any standard they want. So at the time, you had PCIe, you had SATA, so you had all these standards. And I'm just going to put some configurability in the IO ring and allow the industry to be able to configure this. And that's how we're going to scale. And it fell flat on its face at first. And that's because I didn't think about the tools, the flows, the usability of it. The concept was beautiful. It is. And today it still has it. And now they've figured out that problem after I left, unfortunately. So I can't even say I solved the problem, but the idea was brilliant, but I hadn't thought through it all. The user interface and the tools and flows is the part of the problem we often think about last. And it should be actually the first part of the problem that we think about. Okay, we have this brilliant ideas. We can come up with a million of them. That's not the hard part. The hard part is, how is it actually going to be used? And that's what I learned through that journey. And it did see the light of day. It is out there today. So I am very, very proud from the sidelines.
Awesome. If you had never had a crazy Mr. Johnson recruit you to computer science, what sort of career path do you think you might have followed?
Probably would have been a doctor. Because I'm an immigrant, and that's what we do. We're either engineers or doctors. So yeah, that's probably, and I probably would have enjoyed it too. I think that's a cool field too.
I'd rather work with like electrons than body fluids, though.
Oh,
Or
yeah.
sick people. Sick devices over sick
My
people for
brother
me.
is a gastroenterologist, so we'll leave
Oh
it
no.
there. We'll leave it there.
I imagine you've traveled quite a bit. You mentioned you were in an autonomous car in Jerusalem just recently. What's your favorite country and or city in the world, and why?
My favorite country is Israel. I've traveled the world and it's my favorite country to go to. First of all, the food is so good. I love the fact that food doesn't follow the rules of politics. You've got European, Arabic, Indian, spice. You got all those influences in that region because of just physically where it is, and it doesn't follow the rules of politics. That is just the melting pot of all that in that region. And then Israel has the highest number of patents per capita in the world. The innovation that's happening there in that tiny, small region is just amazing to me. We have an office out there and they do amazing work. And like I said, the innovation in just, you see startups everywhere. And it's so much fun to be out there. And then lastly, I just love that directness. They just tell you like it is. If they like you, they treat you like they do. And if they don't, they'll tell you to go to hell and wouldn't want it any other way.
You mentioned that you set strict rules for yourself. Do you have any life rules for yourself that you recommend other people consider for themselves?
It's funny because I just very recently I had a gentleman come to me that said, I've been working long hours. I'm busting my back. My family's got these issues. I feel burnt out. I'm completely burned to the ground. And I said to him, maybe this is a harsh reality, I will take every bit of blood, sweat, and tear you'll give me. That's how the machine works. That's how companies work. And so it is not my job to set your boundaries. It is your job to set your boundaries. It is your job to tell me what you can and cannot do. It is my job to respect them. I will honor them and I will respect them, but I won't set them for you. That's just the rule. I say that to my folks, and I absolutely and honestly will respect boundaries that any individual decides to set. For me, when the kids were little, I wasn't traveling because I traveled so much. I made sure that I had dinner with them every night. I work with Asia, so often calls could go into 5, 6, 7, 8, and there you go. The whole evening's gone. You haven't seen your child, and you've been traveling 50% of the time. I just said things like between the hours of 5 and 8, there's no calls. But I will stay up from 8 to midnight if I have to.
Yeah.
Because that's convenient for them.
Right.
So this just, you've got to set those boundaries. Otherwise, any company in the world, it's not about a company culture. It's just how the machine works. You can't take it personally.
I love that. Yeah. I have from 5 to 8 p.m. every night blocked out as out of office.
There you go.
I'm all about that. Well, speaking of respecting boundaries, we are out of recording time, so I really appreciate you being here. This is fun. I have one more lightning question I got to ask that I forgot. Behind you, I see you mentioned you have a Stevie Ray Vaughan guitar, a Sting guitar. Best electric guitar solo of all time, and why?
Oh gosh, I got to go to Prince.
Oh yeah.
He's my man. Sorry.
All right.
I don't have his guitar, but I would go to him.
Okay. Cool. Well, thank you for being here. This was a blast.
Thank you. I had fun too. Thank you so much.
Well, thanks everyone for joining me today in the lobby. I, for one, will be excitedly watching the IoT and automotive markets. The technology advancements in those spaces are astounding. And honestly, I'm thrilled that we get to watch all this play out over the next few years. We only have one more Moore's Lobby episode left for season 4, and it'll be a good one. We have Bill Vass, Vice President of Engineering at AWS. So you know the drill. Make sure you're subscribed to this podcast. We love reviews, and we love it even more when you share this podcast with your friends and coworkers. I'm Daniel Bogdanoff. Thanks for listening, and I'll catch you next time.